Hello, Algebra 2 Triggers. This is Mrs. Leopold, and I am going to take you through Lesson 1 of Unit 6. Unit 6 is all about trigonometry. You might have learned a little bit about trigonometry in the past. If you were in our geometry class here at SAS, you learned about SOHCAHTOA and right triangle trigonometry. And this unit, we're going to expand on some trigonometric ideas. So the first thing we're going to do before we expand, in order to expand on the ideas, is to talk about angles and standard position. So if you look there at the beginning, it says an angle is in standard position when its vertex is at the origin and the initial arm lies on the positive x-axis. So the vertex is right here at the origin, and then it lies out here going toward the positive x-axis. So that is your initial arm. We're going to rotate that, so you can see this little angle measure here, this rotation symbol. And if we go anti-clockwise or counterclockwise, then we would call that a positive rotation direction. If you go clockwise, right, we start the same thing. We start here at the positive x-axis, and we go clockwise, then we are rotating in a negative way. So anti-clockwise or counterclockwise is positive rotation, and clockwise is a negative angle rotation. And we're starting here at our positive x-axis. So if you look at example 1, we're just going to ask you to sketch these angles that are listed A, B, C, and D to indicate their measures. So one of the things you might want to recall, right, is that the x and y axes are meeting at 90 degrees. So if we were to rotate here from the positive x-axis, we're rotating to the y-axis, that would be a 90-degree angle. And because we want to get 100 degrees, we're going to rotate just beyond that 90-degree angle. So this right here would be about 100 degrees. Is it exact? No, we're just making an approximation. But I am rotating in the positive direction. So negative 60 degrees. I start at my positive x-axis. Because it's a negative, I'm going to go the other direction. So I'm going to go clockwise. And again, these meet at 90-degree angles. So this would be 90 degrees. So I'm only rotating backwards 60 degrees. So I'm not going to get to my 90-degree angle, so that's about negative 60 degrees. Now please note you do need the the arrow on this little curve because you're indicating which direction you're going to. You're indicating to us that you know you're supposed to start on the positive x-axis and go in this direction, start on the positive x-axis and go in the negative direction. Okay, if you want to, pause and try C and D on your own and then check your answer when you're done. So if 250 degrees, we start at the positive x-axis, we're going to rotate through 90 and then 180 and then 270 would take us to here, but we're not to 270, we're just shy of that, so we stop at 250. So your line segment or your ray should have been, prior to the 270 mark. For negative 130, we're going to go negative 90 and then just beyond that, so it is the clockwise direction, so that's negative 130 degrees. All right, so let's look at example 2. You could pause and try this one on your own, right? It says consider the angle theta equals 25 degrees. This is the Greek symbol known as theta, which is 25 degrees. It says draw the 25-degree angle in standard position, and then draw a negative angle with the same initial and terminal arm as 25 degrees. And so just try that. First, maybe sketch the 25-degree angle in standard position. So here I have it. I'm going to go from the positive x-axis, rotate in a positive direction, and that would be 25 degrees. Then it says draw a negative angle with the same initial terminal arm. So we're still staying at the positive x-axis, terminal, and then I have to go and end with the same terminal arm, which is here. But I want it to be a negative angle measure, which means I need to go clockwise to get to here. So if I do that, then what am I going to end up with? Well, if I go backwards, I'm going to have a negative 335 degree angle. How do I get that? Well, one full circle is 360 degrees. So I'm subtracting 25 degrees from 360. So in order to get to that same side, I would have to go backwards 335 degrees. And so here is the indication that I'm doing that. Now these two angles, the negative 335 degree angle, which I can write here, and the 25 degree angle are both called coterminal angles because they have the same terminal side. So they are coterminal angles. Now in actuality, there's an infinite amount of coterminal angles that would end with this terminal side right here, where 25 degrees is. So we're asking you to find one more that is positive. Okay, so why do I say there's infinite? Well, that's because we can go around the circle an infinite amount of times. So I can start at my positive x-axis, and if I went around a positive direction, so if I go around one circle, that's 360, and then I can go 25 to end up here, and so I could do 360 plus 25 degrees, so another positive angle would be 385 degrees. Or I could go around twice. I could start on my positive side, and I can go around 360, 720, right? 360, go around the circle twice, and then add my 25 degrees. So I also could have said 745 degrees, right? Because 720 plus 25. Or I could go around 3 times, or I can go around 4 times. So I can go around the circle an infinite amount of times, which means I'm going to multiply 360 times whatever number I want and then add the 25. I could also do the same thing negatively, right? I could go backwards, negative 365, or negative 335, or I could go backwards negative 360 and then tack on another 335, so I could get negative 695 degrees would be a coterminal angle. So again, that's why there's an infinite amount, because I can continue to circle around the circle. All right, let's look at this last statement on this page. It says one full rotation of a circle represents 360-degree turn. So we've talked about that in geometry. Complete the circle on the right, showing where angle multiples of 30 and angle multiples of 45 would intersect the circle. So we can look over here on the right-hand side and see what's going on. We start at 0 degrees. If we rotate to here, that's 90 degrees. If we continue to rotate, that's 180, then it's 270, and then we go back and end at 360. So here we have a 30-degree angle. Then what comes next right here is our 45-degree angle. And then what's next is our 60-degree angle. And then what's next here is your 90-degree angle. So again, they're asking for multiples of 30 and 45. So 30, 60, 90, 120, 150, etc. Or 45, 90, 135, 180, etc. So pause now and complete this chart on your own. All right, did you get the angle measures that I have in my diagram? Hopefully you did. If not, then have a pause and go back and just redo your math. All right, measuring angles. It says, whose idea was it to measure angles in degrees? And why are there 360 degrees in a full turn? This decision actually dates back almost 4,000 years. Degrees were created by the Babylonians, ancient people who live in the region that is now basically Iraq. So, yeah. So it wasn't us. It's really, really old, and we're just using it. So right now, you're probably more familiar with degrees. You know, if I say, oh, rotate your body at an angle of 100 degrees, you're probably going to be able to do that. But now we're going to learn something new, which is called radians. And it's a different unit of measure, like meters versus feet or something like that. So it's degrees versus radians. And you have a little activity, or I wanted to say your radians you're going to use pretty much after Algebra 2 Trig. You're not going to talk a lot about degrees anymore. You're going to be functioning in radians. So the quicker or the more you understand the radian, the better. You have a little activity you can do on your paper, so you might want to pause and try to discover for your own what a radian is. So it's about a circle and cutting out the length of a string and experimenting and finding out a little bit more about radians. So pause and try that on your own. Okay, so if you did a little activity and you had an actual protractor, you would have discovered that one radian is about 57.3 degrees. And usually we would just, we might say 1 rad or 1 actual radian, but if we don't have a degree symbol on a number, like this degree symbol up here, that means we're probably indicating our angle of rotation as a radian and not a degree. So what is a radian? Well, the simple answer is that it's the angle made when we take the length of one radius, so this radius length right here, if you had your piece of string, and from this point you wrapped it around the circumference of the circle. So we took that and we wrapped it around along the surface or the circumference of the circle, and then this angle of rotation right here would be 1 radian. So if you took that with your string and you did it again, this would be 2 radians, do it again, this would be 3 radians. So our angle to here would be 2 radians, our angle to here would be 3 radians. So what you should have discovered is that a 180 degree angle measure is not quite 3 radians, it's beyond that. And more specifically, it's 3.4 blah, 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 blah radians, which is about pi, which is exactly, which is exactly pi radians. So rotating 180 degrees is exactly pi radians. So rotating 360 degrees, well, if 180 is pi radians, then 360 is 2 pi radians. So we're going to talk a little bit more about that on this page. So it says working in radians. In the circle activity, if you had done that with your string, you would have found that you could have fit about 6 and a bit more radians in a circle. So that means you would have had 3 and a bit for half of a circle. So in other words, or if you were to do it exactly, which I just talked about, to get exactly 180 degrees, you would have to rotate pi radians. So pi radians is equal to 180 degrees. So that means if this is our origin right here, right, we have our y-axis, we have our x-axis. If this was our terminal or our initial side, and we rotated around to get to here, this would be 0 degrees, this would be 180 degrees. Now, what about in radians? Well, this would be 0 radians, this would be pi radians, we just said. So what if we split, remember this angle right here is 90 degrees. Well, rotating 90 degrees is how many radians? Well, if a full semicircle is pi radians, then half of the semicircle is pi divided by 2. Okay, well, what is this right here? What is that angle of rotation going to be? Well, that's halfway in between 0 and 1/2. So what's halfway between 0 and 1/2, or pi over 2 is just 1/2 pi. Well, what's halfway between 0 and 1/2? Well, change this to 2/4, so that would be 1/4. So 1/4 is halfway between 0 and 1/2. What's halfway between 1/2, or pi over 2, and pi? So that would be 3/4, or 3 pi over 4. So we have 1/4 pi, 2/4 pi is pi over 2, 3/4 pi, and then 1 whole pi. So that's if we cut pi radians into thirds. We could rotate pi over 4 units, which is equivalent to what? Hopefully you're seeing that that's equivalent to a 45 degree angle. This is equivalent to a 90 degree angle. What if we rotate 3 pi over 4? That's a 135 degree angle, etc. Okay, you should pause here. What if we cut pi into thirds or sixths? So pause here and try these fractions on your own. Okay, so if we cut the radian measure into thirds, right? So if we rotate through here, we're going to get 1 pi. So then if we cut into, this is going to be 1/3. From here to here is 2/3, and so all the way around is 3/3. So 1/3 pi is the same as pi over 3. 2/3 pi is the same as 2 pi over 3, and 3/3 pi is the same as just 1 whole pi. If we divided pi into 6, we would have 1/6 pi, 2/6 pi, but 2/6 reduces to 1/3, so that's the same rotation as this one up here. We have 3/6 pi, which is the same as pi over 2, which we said was 90 degrees. We have 4/6 pi, which is the same as 2 pi over 3, which is the same as this one up here. And then we have 5/6 pi, and then 6/6 pi. Okay, now let's put it all together for our radians. I'm thinking in radians. So we're going to fill out this entire unit circle with radians. Here, this is our y-axis, and this right here is our x-axis. So first we have our quadrantal angles. Your quadrantal angle, remember, is an angle that has a terminal side, angle with a terminal side on the x or y axes. So 0 is a quadrantal angle. Pi over 2 is a quadrantal angle. Pi is a quadrantal angle. 3 pi over 2 is a quadrantal angle. And 2 pi is a quadrantal angle. Those are the easiest ones. If you understand it's 0, pi over 2, it's like 0, 1/2, 1 pi, 3/2 pi, 2 pi, then the rest might be easier. So your multiples of pi over 4, your multiples of 1/4. 1/4 is halfway in between pi over 2 and 0. 3/4 is halfway in between 1/2 and 1. 5/4, right? 5 pi over 4 is halfway between 1 and 1/2. Halfway between 1/2 and 2 is 7/4. So we have 1/4, 3/4, 4/4, 5/4, 7/4, or 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4 gives us back to 2 pi. Then we have our multiples of pi over 3. So pi over 3 is 60 degrees. So this is 1/3 of the way around. This is 2/3 of the way around. This is 3/3 of the way around. This is 4/3 of the way around. 5/3, and then 6/3, of course, is 2 pi. And our pi over 6's, so this is 1/6 of the way. 2/3 is, or sorry, 1/3 is 2/6 of the way. 1/2 is 3/6. Then we have our 4/6. Then we have our 5/6. Then we have our 6/6 is 1 whole. Then we have our 7/6, our 8/6, which we call 4 pi over 3. Our 9/6, which is 3 pi over 2, our 10/6, which is 5 pi over 3, our 11/6, and then finally we end at 12/6. So 1/6, 5/6, 7/6, 11/6. 1/6 is just beyond 1 whole. 5/6 is 1/6 before pi. This is 1/6 beyond, so 6/6 plus 1 is 7/6, and then this is 1/6 before 2 pi, 12/6, which is 11 pi over 6. Okay, moving on to example 4, I want you to note this statement over here. So it says we're going to find the measurements below, or the measurements below describe angles, indicate where the terminal arm of each angle would intersect the circle. So you're going to draw the terminal arm for each one of these angle measures. The first one has been done for us. So here, we start here, we rotate to, let me get, instead of that, so we start here at the positive x-axis, we rotate to get 95 degrees, so this would be the terminal arm approximately. Now, this is really important for you to note right here. If an angle measure does not have a degree symbol, so this degree symbol up there, then we know that we are talking about radians. So this is degrees, degrees, radians, 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 and radians. So go ahead and pause now and try this on your own, and then you can compare it with mine. Okay, so does your picture look something like this? So we have 1 radian in the first quadrant, we have 3 pi over 4, right? So you should have 1 radian, then pi over 2, 95 degrees, 3 pi over 4, pi radians, 4 radians, 5 pi over 3 radians, 11 pi over 6 radians, and oops, I forgot your 1 degree. Okay, so coterminal angles, we talked a little bit about this at the beginning of the lesson. Remember, recalling coterminal angles are angles who share the same initial side and terminal sides. So they must both share the same initial side and the terminal side. So finding a coterminal angle is as simple as adding or subtracting 360 or adding or subtracting 2 pi radians. So I kind of showed you that at the beginning when we were talking about the infinite number of coterminal angles we could have. So for example 5, it says draw the following angles in standard position and then find 1 positive and 1 negative coterminal angle. So first we're going to sketch 5 pi over 6. So remember, this is pi over 2, this is pi. Well, pi is 6/6. So 5 pi over 6 is going to be just shy of that. So this angle right here is 5 pi over 6. If I want to find 1 coterminal angle that's positive, then I'm going to go around this picture 1 full time, so that's 2 pi units, right? Then I'm going to add the 5 pi over 6. Then I'm going to keep going until I get to here. So what is 2 pi units plus 5 pi over 6? Well, 2 pi is the same as 12/6, right? 2 pi is the same as 12/6 pi. So that would be 17 pi over 6, or you could write 2 and 5/6 pi. But typically we would write 17 pi over 6. If you want to go backwards, you would start here and you could say what's 1 negative coterminal angle? Well, this is negative pi units, and then I have a pi over 6 after that. So the negative pi units is negative 6/6. Add 1 more 6 onto it, so that would be negative 7 pi over 6. Or you could say I'm going to take my 5 pi over 6 and subtract 2 pi. Right? So 5 pi over 6 minus 12 pi over 6 would give us negative 7 pi over 6. So pause here and try the other 2 on your own. Okay, for the second one, did you get an angle of 7 pi over 4 for your positive angle and negative 9 pi over 4 for your negative? For C, did you get 8 pi over 3 and negative 4 pi over 3? Again, those are just one example of a positive, one example of a negative. You could have an infinite amount. You could keep circling around and around and around. It goes around as many times as you want and end on the terminal side. It's up to you. Those are just one example of a positive and a negative angle. If you're not sure about this stuff, you need to ask your teacher. Finally, this last page for closure, you're going to identify which quadrant the terminal arm of each angle is located. So remember, you start with the top right, that's quadrant 1, then we go counterclockwise, so quadrant 2, quadrant 3, and then quadrant 4. So go ahead and pause and try these on your own, and then you can check your answers momentarily. We'll do the first one together. 5 pi over 3. So where's 5 pi over 3? Well, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So 5 pi over 3 is in my 4th quadrant. So try the rest on your own, have a pause, and then look at your answers soon. All right, so you should have had your answers as seen the same as mine. There were 2 that were, I suppose you could say, non-applicable. That was D and H. Those are both quadrantal angles, right? 3 pi over 2 ends up right here on the y-axis, and negative 180 degrees ends up right here on the x-axis. So those are not in any quadrant, those angles. Those are quadrantal angles, and they end up on the x or y-axis. So you can write non-applicable or NA because they don't have a specific quadrant that they end up in. So there you have it. If you have questions, make sure you seek out your teacher. Bye.